Dielmo's geoportal and LiDAR viewer for powerlines is a geospatial tool that allows the user to access all the information of his project and manage it efficiently. For these type of projects, both the cartography and the advanced analysis with technical information for the study of the power line are accessible in an online web portal where you can find and measure all the data without the need of any kind of software or previous knowledge. The interesting thing about this tool is that we can find and visualize all the available geospatial information in a friendly and simple environment. For example, by zooming in, we can see how the mapped elements such as roads, power lines, poles, or buildings are represented on the map. In addition, if we click on any of these elements, we see its description and associated table, which allows us to find the code of a tower or the description of that element. One of the most powerful tools of the GIS is the search tool. From a name or code, it is possible to find any element. The geoportal will suggest all the elements that match the search, and with a simple click, it will take us to the element we're looking for. The particularity of the geoportal applied to powerline studies is that it makes available to the user not only the cartography, orthophoto, or LiDAR data, but also the results obtained during the study of the network in question. In the case of the treefold study, with a single click on the polygon, we can visualize the level and type of risk of treefall on the study line, height of the tree, distance of the tree from the network, etc. We can also find all the analysis that Dielmo 3D has carried out for this project, following the safety guidelines of the area or country in question. The result of complex customized algorithms based on distances, voltages, or study elements is represented in the colored polygons that we can see on the map. If we click on any of these polygons, we will find information related to the risk level, as well as details of the cable section studied, such as span length, voltage, coordinates, codes, materials, etc. For example, selecting this zone, we can see that the data displayed to the user is as follows: the priority, frequency of pruning, fire risk, link to PDF, category of the zone, the type of cable, cable section, transmission or distribution, the span length, station code, coordinates, etc. In addition to showing the worst case in the zone, such as an A1, we can also see the other risks present in the zone with less urgency. The PDF would be the visual summary of everything that exists in a cable study. In addition, this contains by default all the profile and 3D views of the area in question so that the user can have a general and accurate overview of the existing risks in any given area. The advanced function of the LiDAR viewer allows us to select an area and visualize it through the LiDAR data obtained on one or several different dates. This visualization can be done in 3D view or in profile view. For the profile view, we select both the desired profile and the thickness of the profile to be used and press the View Profile button. This shows us the classified area and is displayed according to the codes of the project in question. In this example, we can see the cables classified by voltages, buildings, soil, risk zones by color, and risk zones by vegetation. For 3D visualization, we select the region we're interested in and press the 3D button. This way, the LiDAR viewer shows us the point cloud corresponding to the selected area. Within the 3D LiDAR viewer, we can move our camera using the mouse. By left-clicking, we can rotate the view, by scrolling, we manage the zoom, and by right-clicking, we fix the center of the camera on a specific point. The main functionalities of the LiDAR viewer are: load or save LAS or LAZ files, modify the colors to represent the point cloud, choose the type of navigation, choose the type of view based on north, south, east, west, and zenith coordinates, choose scaling options for the point cloud, and measurement tools. In addition, if we compare the PDF report with the 3D LiDAR or profile results, we see that the distance measured in the report corresponds to the reality when measuring in the 3D or profile view.